Okay, folks, let's get started. Thank you everyone for coming over on the weekend. My name is Muguda, and today I will talk about the topic that's near to me. It's on software engineering. Theory without practice is empty. Practice without theory is a personal mantra of mine. Theory without practice. Theory without practice is empty, practice without theory is blind. This mantra resonates with me and my observations with a couple of decades in the software development industry. You can follow me on LinkedIn as well as Medium. Disclaimer, some of the pictures or most of the pictures in the slide deck are from Google searches. What's wrong with this? Okay, let's focus on the reading. So, the Tamil alphabet has overloaded letters for Ka and Pa and Cha and Ja. Gobi is a word which is not Tamil. And of course, Manchuria is far from Tamil Nadu. So, when the word Gobi Manchuri reached Tamil Nadu and somebody wrote it in Tamil, they wrote Gobi Manchuri. Somebody read it as Gopi Manjuri. And even when they had a chance of writing it in English, it became Gopi Manjuri. This is an example of sequence of events manifesting in not so pleasant light. Humans are not immune from logical thinking mistakes. We tend to conform to a group. We tend to be individually smart or somehow collectively dumb. And we have narratives being planted across the board. So, for example, people try to tell us that all of the parties is going to be more stable government and two allies for BJP. Things like this, you will have all the problems. Software engineering is not immune from these kind of thinking anti-patterns and practices. And critical thinking is a tool which we can employ to lessen the impact of past narratives, group thinking, and other cognitive biases. They say that for every complex problem, there is a solution which is simple, elegant, and wrong. And we as humans aspire for simplicity, and we often compromise for simplicity at the sake of correctness. And software engineering is no different. How many of you have heard this statement? There are two hard problems in computer science: cache invalidation, naming things, and off by one errors. It's a video of saying the three hard problems. But how many of you have encountered off by one error in the last few years? Okay, I guess you guys code.
This sentence itself is a hop by one.
Huh?
The sentence
That's a
itself is
wiki way
a
of saying that, but yeah, we talk about writing code. That's because now programming languages provide iterators out of the box, and it's no longer a hard problem. And even otherwise, I don't think it's a hard problem. How about cache invalidation? Is it a hard problem? You employ change data propagation, change data capture, and you propagate it. Problem solved. So they are not hard problems, and they are not the only hard problems in software and computer science. But it is this witty way of saying tends to capture attention. Other similar statements are radical oversimplifications, and another manifestation is fundamental errors, errors which are basis for other abstraction assumptions made upon. In the world of prepositions, we have all of these variants, some which are simple, spoken confidently but are wrong, some which are wrong but simple, elegant, some which are fundamental and wrong, some which are widely believed, simple and wrong. In this talk, I'm going to propose a hypothesis which I believe is fundamental, simple, correct, but it is not widely believed. This is a search I made on Google recently. I searched for software visualization. All the videos that pop up are about data visualization and not software visualization. Additions are also very similar. There's a lot of emphasis on data and not enough on software. This is my proof that software visualization is not very well understood or not a popular area for us. They say that all or many problems in business or life, if you boil them down, they start with communication. When people communicate, they need to understand each other and then they need to agree with each other. If they understand and agree, it's great. If they don't understand and agree, it is bad. This is not as unlikely as it seems. I have been plenty of conversations. People are agreeing without understanding and understanding without agreeing. So 4 combinations I've seen. So I still say that communication is an understood problem in software engineering. There are 3 modes of communication: natural language, code, and visualization. I'm going to compare and contrast natural language with visualization. I guess most of you would have seen this video. A simple comma could change the meaning of this sentence. More jokes on programmers. These are examples of how natural language can be confusing, can have multiple meanings, and can lead to confusion. Can you folks navigate to the beginning of a second sentence? Can you navigate back to the beginning of the first sentence? And then navigate to the beginning of the third sentence. Was it easy? Why is that? I'll come back to that. This is a representation of a graph. Can you tell me how many edges are connected to the node 3? So each one represents a source and a destination of an edge. Was this pass better or is this better? Why? Why is visualization helping you? Exactly. So you could skim through this and find 3 and then do a local reasoning and you could find the number of income. So text is, you think of it as a singly linked list. While diagram is a graph. So you have theta E traversals and theta B traversals. Going back, so it was like navigating a linked list. You came to here, then you went back all the way, and you came. That is why this traversal was hard. Okay. Please raise your hand if you spot the odd shape here. What odd MP? How about this one? This one? Yes. Most of you, I think, would have got it in a few seconds. These exercises are telling you how fast is human brain equipped to deal with visual information. You might know the story of benzene. The scientist who conjured the shape of the benzene molecule, he dreamt of a serpent swallowing its own tail, and that helped him formulate the shape of benzene. This is an example where visualization helps in problem solving. So I'm trying to impress upon you how intuitive it is for humans to consume visual information. So natural language can be verbose, can be ambiguous, has limited scope. It supports exactly one axis of navigation and can be inefficient. If you look at this, how would you describe, in one of its describe this shape? Okay, let's go with square. That's fine. Two rectangles, fine. There are grid of dots. Yeah. There's a grid of dots, and one of you called it as a square, one of you called it as two rectangles. You could connect these into a higher shape and say that you could describe all of them to be part of the same row, same column, and you conjured up bigger abstractions even though nothing was meant explicit. How about this one? What does it remind you of? Yeah. You thought more of it being more than a bunch of 5 overlapping circles. How about this? How to describe this part, this shape for me? Two groups. Yes. When you say two groups, two groups of 3. So this space and this space was made, you perceived it differently, and you were able to quantify this as 2 different groups. How about this one? What's that?
Path.
Yes, but I now told you it's one continuous thing. You were able to collate all of them together and say it is one single thread. How about this one? It's a, what is it? Yes, even though it's the broken parts of the rhombus, you were able to map it to, your mind applied closure property to this and it got it the rhombus. Okay. Would you attribute this dot to be almost all of you had the same interpretation of these pictures as what was mentioned. This, I think, should tell you that there's common thinking patterns across all of us when it comes to visual information and interpretation. So when you try to communicate visually, these are the levers, these are the variables we need to figure out. Position, size, shape, value, color, orientation, and so on. Even in our IDEs, we tend to exploit some of these qualities. We exploit indentation, we exploit spacing, we exploit colors to communicate different aspects. So this is another example for you how we exploit more information visually to make our life better. Who can tell me what Huffman encoding is?
So encoding it any characters using zeros and ones based on frequency of occurrence of each character.
Okay. So why don't we do? Why is it dynamic encoding and why is it not static encoding?
Because it depends on the frequency of occurrence of each character.
No. Yes, but why do we tailor that?
To optimize the number of bits.
Yes. Which of this is easy? Static encoding or dynamic encoding? I'm not talking about Michelle, I'm asking about which of them is easy.
Static is easy.
Easy. But we take the harder approach because it's optimization in a different. So this is a representation. The cost of encoding the data, the cost of transmitting data, the cost of decoding data tends to be lesser than the cost of transmitting raw data. This is the math behind choosing of the dynamic encoding psychology. This is true even for human to human as well. I am encoding the information, what I want to communicate as these slides, and you are decoding them. If I had chosen a verbose, redundant communication, it wouldn't have been the best of communications. So, the model of the cost of coding, encoding can be applied even to human communications. Talking about regular expressions, if you could not use the star plus question mark here, how easily would you be able to articulate the regular expression for email for email addresses? So there is a one-time cost to interpret the meaning of these symbols. And post-learning that, it becomes easier to interpret. So one of the colleagues I showed this told me that the regex is wrong. This he could identify because of he understanding the notations. So he prevented the Gobi Manchuri situation in this context. So as humans, to think, we have a meaning for the plus, we have a meaning for the star, we have a meaning for the question. These are the concepts on which reasoning about this is facilitated. Lower level abstractions are not going to be always beneficial. Chunks do this. What's 12 times 3? 36. What is 16 plus 28? What is 463 multiplied by 69? I thought you guys are smart. Jokes apart, the first two calculations were easy because it could fit into a short-term memory. The third problem has too much data to be fit into a short-term memory, hence that calculation was hard. Okay, this is an example from, say, from maps. Maps have notations. Had they chosen not to use these notations, the map would either be unusable or it would be quite clumsy. So when we are communicating, all of us have limited energy and attention. If we choose verbose communication models, either it is shallow communication or it is inefficient communication. So we need to tailor our communication to fit the limits of our short-term memory. And chunks and notations are requisites for efficient visual communication. So going back to the Huffman encoding, for us to communicate better, we need to work harder to communicate precisely. So the saying, the more we spit in peace, the less we bleed in war, is the human equivalent of Huffman encoding. I work at Google and I work on a software which takes snapshots of disks. And I'm trying to communicate, the color indicates the version of data. The circles indicate the act of snapshotting. And the triangles indicate mutation of the disk. Imagine me trying to communicate this or via text. So the encoding, the notations, the chunks, the notations, and the encodings via visualization I was able to communicate this in a precise way and in an unambiguous way to my screen. Can somebody solve this problem for me?
Four.
How did you solve this?
X plus 2x.
There's no X here. No, but there's no X.
Yeah.
So the point is, I'm pretty sure all of us did this now. I don't mind. So we took from the world of Alice, Bob, A's and combined and moved to a world of mathematics which had symbols and operators. Solved this problem here and we came back. This kind of moving from a problem space to a model space, solving a model space and coming back is fundamental to human thinking. I should have picked a more Indian model. These are three different maps of America. One of them shows physical attributes overlaid with state boundaries. Other one of them shows state boundaries with state names. And this has more information, things like the interstates and borders. Why do you think there are three different kinds of maps?
Audience is different.
So is different. So the same entity, we had different subset of information shown in different maps, and that is the prerequisite of usability of that map. So maps are used if they omit the necessary information and include necessary information. The same is true for models. If code was a reason or the mode of communication, chances are we wouldn't communicate. So this is a visualization of given a bunch of information, we capture a subset of this as models and we create a pictorial or visual representation of the same. This was used in the maps here. This was used here. So this is pretty much how we can solve most problems we operate. So the star plus question mark, the plus equals, those are the concepts. They together form a set of rules which we operate on. And these rules are applied in the context of cognitive models. So this is equivalent to the model of the map. This is equivalent to the legend. This is a representation of this. This is how we can model, we can look at any problem. Going back, if there are multiple recipients of information, the cost of defining a schema, the cost of encoding information, the cost of learning the schema, the cost of reviewing, this is the code, this is flavor 1 versus having a verbose communication. We need not have to learn the schema in every instance. If you know how to read a map, you are able to read a different map, a similar map. So the rest of the talk, I'm going to focus on the various schemas which we can use for modeling and visualization.
What is N there?
The number of recipients involved. Okay. Why do we have different relatives? Yes. And this dawned upon me that there are parallels between data types and code-based abstractions. Text-based community model is equivalent to a string. Matrix is equivalent to, say, a table, the descent table, truth table, and so on. The way we have multiple data types, it makes sense having different kinds of models. Talking about categories of information. Information can be data. Information can be code. Information can be execution or flow. Information can be history. Information can be actors. Information can be time. The problems which we work on can have one or more of these dimensions. And the types of schemas I'm going to talk about capture, work with one or more of these categories. So the first model I talk about is the use case model. This talks about, say, the various kind of roles, users interacting with the system. The high-level use cases, if they extend or reuse other use cases. You can think of, there's a map of India, there's a map of Karnataka, there's a map of Bangalore, is a map of outer reserve. So this model tends to operate at the periphery or the edge of your soil. It communicates the various use cases that users, the system has. Talking about data, I guess most of you are at this in school. This is a logical scheme. It focuses on entities, attributes, and relations. Once we have understood this schema, we can focus on the problem at hand instead of figuring out what is the meaning of each symbol. So I'm trying to impress upon you the various schemas. Yeah, ER models have this notation of 0 or 1, you can say max and min. There are ways to capture information about various data models. Talking about classes, classes can have interesting relationship between them. You can have subtypes, you can have implementations of interfaces, you can have interfaces which compose on other interfaces, and so on. Given this rich set of relationships between classes, the UML class diagram is a way of capturing this information in a concise, precise, and ambiguous way. Here I spoke about data. Here I spoke about classes. Data flow diagrams is a marriage between these two dimensions. They focus on the data flowing between different classes or actors. Like a physical map is useful in one context and a logical map and a political map in a different context. Depending upon the context of your problem, you may want to employ a class diagram or a data flow diagram. So, this is another diagram which can model software at a high level of abstraction. You have components, you have boundaries, you have interfaces it provides, you have to consumes. This is another powerful schema for. I guess most of you are familiar with sequence diagrams. Another visualization that I found useful, especially which involve multiple actors, is the activity diagram. So it talks about responsibilities or activities for different actors. It also focuses on things like these things should happen concurrently, these things should have finished before you proceed to the next activity. So these kind of visualizations can be modeled, this kind of interactions can be modeled elegantly by an activity diagram. State engine diagram. Over time, what happens to an entity will be captured using state diagram. Go on. There are timing diagrams which tell you what happens. These might be helpful to detect things like deadlocks, live loss. Reasoning about these scenarios are possible using the timing diagrams. Component diagrams. When you have multiple entities which are linked with each other, what can happen if one of them gets deleted? Broken references is a viable option in some scenario. Delete the reference entity is an option in another scenario. Failing the operation is valid in some scenario. So we had to draw the decision tree saying in our application what are the different choices, and we use this to reason in our day job. To summarize, there are three styles or three modes: natural language, code, and formal visualization. Natural language tends to be verbose, code tends to be verbose actually, while visual models tend to be low on the verbosity trend. Natural language can be precise, low on precision. Code tends to be highly precise, so is problem analysis. Navigation tends to be low here, while these tend to be low. There are more visualizations. While I spoke about value visualizations, I still would say there is value for text in our communication. Describing the context, describing the invariants, describing the principles, rationale. This is where I would still advocate employment of text. When to visualize well? When you design, when you whiteboard, when you debug, when you document. Stop. Okay. I'm open for questions if you might have any.
Essentially,
So there's two things that I'm trying to take away from the three. So one is if the communication, and all of this is my question. One is if the communication is between developer to developer, people who understand the details, then a bunch of these become useful. However, some of these, while taught in colleges, most of us have lost the true definitions of it. For example, what's an interface, how do you define a service, what's a component, what's an artifact. So the standardization of these diagrams, A, how do you build to that? That's first question. And that communication is essentially limited to let's say, tech audience. B, a lot of these diagrams or a lot of communication is not limited in a software development within the developers, right? It's actually communicating outside. So that outside communication, the usage of standard UML diagrams, or let's say for enterprise architecture, something like TOGAF diagrams or whatever, Archimate diagrams, becomes really difficult because the person whom you are explaining it to is not again aware of the terminologies used in those diagramming contexts. And most often, I find myself limiting to using something like a swim lane or a decision tree. This is a very specialized diagram. So how do you solve for that, and how do you select what's the right form of diagramming? Because the simplicity of the diagram also becomes important. If I squeeze, I don't know, maybe 5 swim lanes, 20 different activities, each swim lanes, that becomes unreadable or unconsumable. So that's the second part of the question. And third is, visualizing softwares is a problem which is very, very less focused upon. Yes, as you started,
yes.
Right? Data visualization, you jump at it and you throw that word around, you'll get probably 20 different tools, 100 different startups trying to solve it. But if you want to do software visualization, you tend to go back to traditional diagram where you have model architectures or decision tree kind of it. There's very limitation in terms of tools available or a gear towards it. So what can organizations do to promote this more, and how can they think of it? If let's say, and I ask this question, position of let's say I can influence them. So what should I tell my leadership that how can this benefit them? So we actually ask questions.
You had many subparts to your question.
Yes.
Let me try to answer. How many of you understood or knew before this conversation the various different types of models I spoke about? More than, say, how many of you knew more than 2? Okay. How many of you knew more than 4? Fine. So the first thing I want to emphasize is the limited understanding even among engineers. People chose not to include, not to overload this, because we needed new consonants to represent and and. they chose not to for reasons I don't totally understand. But one of the things I'm trying to advocate here is these problems have been solved in the industry. How to model concurrent activities has been modeled. The problem is, do we think as a community is it required? So, I have been told in uncertain terms that nobody uses UML anymore because it is not cool. So, that is one of the things I am trying to promote in this, saying that, hey, you have live examples where I could advocate to you, where you could deduce that these formal ways of doing things is beneficial. Second, even if it is not for interpersonal communication, even if it is as engineers trying to decipher something, I still think these tools are relevant. I have worked among the best companies, I guess, that are there in India. And people still try to communicate all of this using words, because nobody is actually broken that chain and say, hey, real communication is beneficial. So I'm trying to impress upon you people who have come here on a weekend, trying to become better engineers and architects, that there is value for visualizations. Now, you will always find, every time I'm here, there will be a question saying, how do I, these ideas are great, Naveen, how do I convince my manager, my director, my VP? Those questions are this is the manifestation of the same problem. So, I have applied this in my day job and have benefited. I am trying to start a fire which you people will take it back to your organization. Some of those fires may be extinguished, but some of them might not. That is the intent of this. Now, this is an example where I had to concoct my own notation. This is not a formal thing, I had to design it myself. So, you might have to do something similar in your organization, interacting with a non-technical person or a person with a different domain, a different nature of work. This might be a tactic that you can apply at your job. Now, software is assumed to have a low cost of change. That is not always true. So, we still have the Gopi Manjuris of software engineering. And I'm trying to impress upon you smart people that, hey, try it out when you debug software.
What tool do you use?
So, in the design software, you can apply this. When you debug problems, you can apply it. You can do this. When you document this, you can do this. Hopefully, you can convince your peers, your managers of these by applying them in your job. And hopefully, the community of people who adopt this will increase. Did I answer all of these parts?
Yes, by far and large. I think the last was around tooling, but in retrospect, I think tooling is not really the problem. I think it's the mindset that needs to change. Tooling, and you can literally put it up on a whiteboard and solve it.
Tooling and knowledge.
Yes, obviously.
So, somebody has a question on tools?
What tool do you use? Yeah, what tool do you use in general to generate these diagrams?
There's a software called Model.io. There's a software called Plant UML. Lucid seems to be way better compared to Draw.io.
Which one?
Lucid.
It's a lucid chart.
And Again, if you want to go to Eclipse and those things, you have those plugins. Yeah, different of them have different cost models.
So, how did you pick up this understanding? If we can say with experience game, but something going back with your very first statement, theory without practice, how do you begin your theory?
I started my software development career when people used to care about these things. I work with people who care about these things. I have gone through decades in the industry where everybody else do not believe in this, but I continue to believe in this. Tooling has been a problem. I have had to work around different ways of working around the tools. But the complexity in the software engineering has gone back to a phase where I believe these mindsets need to come back.
In general, the technical documentation, the importance of going in depth of the design is actually come compared to
No debate. As the number of people in our industry increases, I think the average level falls.
as we have it in civil industries, right? Those who work in the background for technicians, more than them, that is the value. So
Yes.
user manual gets more important than these kind of technical applications.
And interestingly, there are better utilizations in those documents than technical communication. Yes.
I don't know if you have included this in your presentation, but I'm just going to throw it out. So what stops me to visualize something is I don't know where to, sometimes in some problems I know where to start, but in certain cases I don't know how to create those components at times. It's easier when